Welcome back to the online sessions for radiographers and students organized by ISRT Thrissur Academic Club under Project Umbrella. Episode 2 Anatomy for Radiographers Part 2. In the previous session, we have described out the anatomical planes, terms for movements, etc. In this session, we are describing the basic things or basic ideas about bones and cartilages. What is skeleton? Rigid supportive or protective structure or framework of an organism, especially the bony or more or less cartilaginous framework supporting the soft tissues and protecting the internal organs of a vertebrate. That is the simplest definition of a skeleton. Then we are going to discuss about the bones and cartilages. Bones histology. Then what is histology? The study of the form of structures seen under the microscope, also called microscopic anatomy, as opposed to gross anatomy, which involves structures that can be observed with the naked eye. The word anatomy comes from the Greek ana, meaning up or through, plus tome, meaning cutting. Anatomy was a cutting up because the structures of the body was originally learned through dissecting it. The word histology comes from the Greek histo, meaning tissue, and logos, meaning trace. Bone is a mineralized connective tissue that exhibits three types of cells: osteoblasts, osteocytes, and osteoclasts. Bone exerts important functions in the body, such as locomotion, support, and protection of soft tissues, calcaneum and phosphate storage, and harboring of bone marrow. Despite its inert appearance, bone is a highly dynamic organ that is continuously resorbed by osteoclasts and neoformed by osteoblasts. There is evidence that osteocytes act as mechanosensors and orchestras of its bone remodeling process. We know there are three types of bone cells, that are osteoblasts, osteocytes, and osteoclasts. What is ossification? Before going to these cells, we want to know a simple term, that is ossification or osteogenesis. Ossification in bone remodeling is the process of laying down new bone material by cells called osteoblasts. Ossification in bone remodeling is the process of laying down new bone material by cells called osteoblasts. Okay, you can go to osteoblasts. Osteoblasts are cuboidal cells that are located along the bone surface, comprising 4 to 6% of the total resident bone cells, and are largely known for the bone forming function. These cells show morphological characteristics of protein synthesis cells, including abundant rough endoplasmic reticulum and prominent Golgi apparatus as well. Osteoblasts are derived from mesenchymal stem cells. We can call it as MSC, mesenchymal stem cells. Next type of bone cells are osteocytes, which comprises 90 to 95% of the total bone cells, are the most abundant and long-lived cells with a lifespan up to 25 years. Different from osteoblasts and osteoclasts, which have been defined by their respective functions during bone formation and bone resorption, osteocytes were earlier defined by their morphology and location. The osteocytes are located within lacunae surrounded by mineralized bone matrix, wherein they show a dendrite morphology. They show a dendritic morphology of a dendrites, that is dendritic morphology. The morphology of embedded osteocytes differs depending on the bone type. For instance, osteocytes from tubercular bone are more rounded than osteocytes from cortical bone. Once more, osteocytes from tubercular bone are more rounded than osteocytes from cortical bone, which display an elongated morphology. Then the third type of cells are osteoclasts. They are terminally differentiated multinucleated cells which originate from mononuclear cells of the hematopoietic stem cell lineage under the influence of several factors. Furthermore, there is evidence that osteoclasts display several other functions. For example, it has been shown that osteoclasts produce factors called clastokines that control osteoblasts during the bone remodeling cycle. Once more, osteoclasts produce factors called clastokines that control osteoblasts during the bone remodeling cycle. Osteoclasts are not only bone resorbing cells, but also a source of cytokines that influence the activity of other. We can summarize the three: osteoblast, osteocyte, and osteoclast. Osteoblast is a bone former. At the same time, osteocyte is a bone maintainer. Osteoclast is a bone destroyer. The other term is resorption. Osteoblasts are young cells cuboidal in shape, while osteocytes are oval in shape mature cells. At the same time, the osteoclasts are irregular giant cells. In osteoblast, it contains basophilic cytoplasm. In osteoclast, eosinophilic cytoplasm. Basophilic cytoplasm is seen in osteoblast. Eosinophilic cytoplasm is seen in osteoclast. In osteoblast, large endochromatic nucleus is seen. In osteocyte, single small elongated heterochromatic nucleus are seen. In osteoblast, alkaline phosphate activity is positive. In osteoclast, acidic phosphate activity is positive. Osteoblasts are derived from osteoprogenitor cells, while osteocyte is derived from osteoblast. What is the case of osteoclast? They are derived from blood monocytes. It shows phagocytic activity. We want to know the final point, the last point, once more. We want to discuss it once more. We want to read it once more. Osteoblast derived from osteoprogenitor cells, while osteocytes are derived from osteoblast. Osteoclast is derived from blood monocytes. Shows phagocytic activity. Phagocytic activity, that's an important point or an important characteristic of an osteoclast. Cartilage histology. Supporting connective tissue, the cartilages, tolerates mechanical stress without permanent distortion. The firm consistency of extracellular matrix. That's the reason. Then they are resilient and they are without blood vessels. That's avascular nature. Without blood vessels, the absence of blood vessels are known as avascular in nature. What are the functions of cartilage? Supports soft tissues shock absorbing and sliding area for joints, essential for the development and growth of long bones. Cartilage composition is the next topic. It contains cells and extracellular matrix, or it's formed by cells and extracellular matrix. There are three types of cells, like bone. In bone, the cells are osteoblast, osteocytes, and osteoclast. At the same time, in cartilage, the cells are chondrocyte, chondroblast, and chondroclast. What are their characteristics or what are their functions? Chondrocytes synthesize and secrete extracellular matrix. They are located in matrix cavities called lacunae. In the case of chondroblast, they synthesize and secrete extracellular matrix like chondrocyte. What about chondroclast? Belong to mononuclear phagocyte system, involved in destruction of cartilage. In the case of bone, we know the third one, the osteoclast, is a bone destroyer. Osteoclasts are bone destroyers. In the case of cartilage, chondroclasts are cartilage destroyers. And what about the extracellular matrix? The two types are there: amorphous ground substances and fibrils. There are three amorphous ground substances mainly: glycosaminoglycan, proteoglycan, and structural glycoproteins are there. What about fibrils? Collagen 2, collagen 1, and elastic fibers. Collagen 2, in the case of collagen 2, there are no fibers are formed. Fibrils with diameter of 20 nanometer. It's a very, very, very small in diameter, 20 nanometer. In collagen 1, they form fibers in fibrocartilage. And elastic fibers in the case of elastic cartilage. So, fibrils and amorphous ground substances are together known as extracellular matrix, are contained by extracellular matrix.
We are winding up this session. In this episode, we discussed the very basic ideas about the composition of bones and cartilages. Without knowing these ideas, without knowing these basic things, we cannot go through the further topics like types of bones, types of cartilages, etc. This module is prepared by ISRT Thrissur Academic Club under Project Umbrella. Thank you.